Hello. Hello.
Srinivas, you are audible, Srinivas.
Yeah. Okay. Sorry. Some technical issue. Yeah. Let's wait for one more minute. Let few more people let them join. Yeah. I think the count is increasing. Wait for one more minute. Sorry for the delay. Yeah. Good to go. Hey, good afternoon, everyone. Firstly, we want to thank all of you for making this technical session series a grand success, and thank you for joining us for today's technical session 6 of our webinar series, Enabling Embedded System Designs. Okay, myself Srinivas, and I am the Senior Digital Marketer and Strategy Planner at FiTech India. Before the session starts, a small intro about FiTech. FiTech provides world-class support for OEMs and ODMs seeking the high-quality embedded hardware and software solutions around the ARM-based processor technologies. We are an end-to-end solution for all stages of embedded system product development. Yeah, coming back to this today's session. Today we are presenting eLinux application program for IoT product development, presented by Mr. Vasudev, the Managing Director of FiTech India, and Gopal P, the competency head in FiTech India. Just a little housekeeping before we get started. Yeah, if you have any questions during the presentation, please type them into our chat box. Okay, which you can find at the right side. Yeah, I'll bring them up during the presentation, and we will also have time for questions at the end. Okay. Yeah, you can also find this live stream on our YouTube channel and also on Facebook page. To watch this session again, the recorded will be available on our YouTube channel. Please subscribe so you will get the latest and the former session updates. Now, without further ado, we will turn the time over to the panelists. Yeah, over to Mr. Gopal.
Yeah, thank you, Mr. Srinivas.
Yeah.
Yeah, good afternoon, all of you. Gopal. So, first of all, thank you very much to all of you, all participants, to join with us. So, since 1.5 months or 2 months, basically here we are conducting open sessions as well as technical sessions. So who are like following our series, this once again, thank you very much to all participants who are the following the technical sessions as well as open sessions provided by the FiTech. Okay, it's just basically it's a great opportunity to build the ecosystem with multiple industry partners. Even we have collaboration with even we do having more technology, open source and handshaking ecosystem model we do work, and there we are working with multiple advanced technologies. So as you know, the FITech is one. We have our open source hardware manufacturer here. FITech India is passionate. It is provided, and to the launch 2019 we have a great one of the open source industrial rugged board we launched. So this hardware is very much playing the key role in industries, and we are calling them, it's an industrial grade rugged board. And as you know, the last session, some of the couple of sessions, we talk about this board features and the other variants. So today talk is purely, it's a technical session. Today I'm just I want to show you some information about that, how we can make use this kind of open source hardware which is available in market. Okay, so here sorry, and now basically, as you know, this today's topic we are discussing, like we are talking about eLinux, embedded Linux application programming for IoT product development, right? So some of you guys, like I hope there are masters are there are some engineers are there. I hope I just want to give that from the scratch. There is a few points, just give me let me give you from the scratch points, the basic points, like what is exactly embedded Linux part. Okay, so using this embedded Linux part, how this embedded Linux is just sat on open source boards, open source hardware, and how we can make that IoT model products, IoT model products. So here in this scenario, here I don't talk much about the theoretical part. So parallelly, just will next 5 to 10 minutes, we'll just go to the how the usage of this open source hardware with a practical visibility. You can able to see that. So now the thing is that, so how we can basically this IoT products which is available in market. So of course there is a before that, going to this IoT product development, we have the buzzword is that eLinux application programming. So eLinux, embedded Linux part, most of you know this Linux is there. Okay, Linux, what exactly the Linux is? Linux is an open source contributed kernel source which is available in directly as I know, it's an open source model, right? Directly we can download from the online, and you can just make your PC ready with your general Linux kernel source. Okay, so on demand we can just have load, or you can just install your packages as and when required. In a similar way, what exactly the embedded Linux is that? So here now I'll give you the basic just one or two differences between Linux and embedded Linux part. So assume that your Linux is a general purpose operating system. So now here we have more services which are integrated services. I mean to say that process management, memory manager, all stuff like in the form of files, it was integrated with some policies, that this that basically we are just loading into that one of our PC or some other architecture itself. So this is generic Linux operating system have more and more of services. Even though we don't use those services, also it is a part of the Linux, it is available. So now come to this embedded Linux part. So embedded Linux is one, it is a very lightweight, minimal resources, which is purely with respect to the hardware, open source hardware, we do customize the generic operating system into as per the board requirement. We make minimal that OS services, kernel services, and deploy into the respective ARM architecture, right? So here, assume that the one key point here, the Linux operating system, generic Linux operating system, say it's a 500 MB size. Now your embedded Linux is come to that. It is ultimately is the less than 20 MB. It is the size. It's a very less weightage and lightweight. That operating system having that multiple the very limited resources. With the common limited resources, the board get in like flash, and this we just ported the generic operating system into the embedded Linux operating system. Okay, so we are just making porting. There is a porting, meaning that it is just not like a flashing. There is a key points we must remember. Porting is the activity we do customize the services. Flashing is the activity we just flash or dump that your Linux operating system into that respective ARM versions, ARM platform, open source hardware. Okay. So on this scenario, you please come out from the confusion here. Most of the guys, you just thinking about that porting is meaning that we are just flashing the OS image into the board. No, porting is one activity. It is we are customizing the we are customizing that your operating system with respect to the hardware. I'll share my presentation. Don't worry about that. I just have a patience. I just come up with this practical scenario. I'll share it out. Now here, the very simple thing here. As you know, we are conducting this open session and technical sessions part. Open session is purely talk about that multiple various industries, and the other hardware players will just introducing that multiple technologies. And now technical session is what technical sessions are purely talk about that how we can get hands-on on this particular any open source boards. Okay. So today's technical session is purely like how we can start work on one particular industrial grade hardware. That is already we know rugged board. Let me show you that. Let me show you the complete the board, the how which is customized, the complete compact embedded Linux operating system which is resides inside the board. Inside the board, once you just start boot the board, there will you can see that the multiple the services whatever it is enabled. Okay, yes. So the one which is we are going to discuss, and now whenever the board is ready, meaning that we are just working with the eLinux, right? We are working with eLinux. Make sure that your eLinux is ready. We are just bring up that one of the open source hardware.
Gopal sir, your screen is not visible.
Yeah, I'll just share. Please have 2 minutes. I'll share it. There is a bit of technical issue. I'll just share it. Have a patience of 2 minutes. Now here. So here, what exactly I mean to say, once eLinux is get ready, now how we can make that the programming, application programming, what exactly required application program. So once your hardware is ready, so hardware which is having that some configuration. So how we are looking that your PC, or you're looking that your mobile, how you're looking that electronic gadgets, electronic devices. Every device have some configuration. In a similar model here, we are having that one open source hardware. This open source hardware also have some basic specifications and configuration. So the configuration with respect to that, we have a IO peripherals. And here we have communication devices, peripherals, and here we have a memory devices, and here we have a hardware peripherals and software drivers, everything which is integrated. Got my point, right? So now, so today activity or today agenda is that some list of peripherals like IO peripheral programming part at the same time, and UART the serial programming, how we can able to that, and how we have a memory device interfacing. This the currently this today's session I'll try to show you. I'll try to show you, and you please have a patience. Just have a look onto the screen, and moreover, this session it's very much helpful to that those who are working with microcontroller and start migrating to the microprocessor activity, and those you are new to that embedded Linux part. It's one good session for two great startup today. It's a great startup today for you. You can start initiate that any of regular open source hardware easily, how we can start work on it. So without any fear, like how we can just enable that board on power on the board, and how we just make interface the peripherals without writing application programming. And after once we have a capability or confidence enough to that peripheral on a peripherals, like slowly we'll move it to that C programmer. We are just become a C programmer to make interface the peripherals one to one by using simple embedded C programming, and start you can test it with this hardware. Right, for that there is some components are required. The components which we are very simple. Now we are working with two pieces. Now we are working with two pieces, and even we are working with two operating systems. One is Linux and another one is embedded Linux. Parallelly we are working with both operating systems. You know one thing, yeah, a PC having Linux and your board having that embedded Linux. Now you just for cross checking, whenever you start boot your Linux operating system. Prasanna, could you please see that somewhere it is noise here? Could you please ask them to mute, or you can just you can mute. So now here, this now continue to this. Like here, we are just working with two PCs here. One is that Linux PC, as well as another one is an embedded Linux PC also. So embedded Linux PC just booting. While booting that embedded Linux PC, you can able to see that the multiple services what is enabled, like SPI, like CAN, like I2C, like USB, like UART, like GPIO. What are the basic services which are enabled? And we make that a small footprint of the OS image, and we just flashed into the board. So that's what we are able to see that while booting the embedded Linux PC. Okay, now as a similar model, like once you boot your Linux PC, you can able to see that while booting the right side, okay, something, just a list of that the services which are bring up, or list of the services which are trying to executing them one after the another. So the slight difference you can understand. Okay,
Hello.
I hope it is clear.
Yeah, Gopal, sir, sorry to interrupt. Your
please.
Screen is not visible, sir.
I'm just sharing now. Just give me 1 minute.
Yeah, you please share and you start that session.
Yeah, sure. So now here, okay, give me 1 minute. I'll share. Yeah, sorry to interrupt you. Here, I'll just try to discuss these few points here. I'm audible, right? Hello?
Yes, sir, you are audible, sir.
Yeah, yeah,
Yes,
great. Thank
yes.
you. Yes, yeah. Now here, today just our agenda and the technical session, purely we just going to get into that peripheral interfacing. The list of peripherals you can understand here, GPIO, and how we just without writing any how without writing any kind of application programming, how we can able to just start, will come to know is it that peripheral is working or not. And for that, what exactly the file system which is supported in kernel, that we're going to see that. Okay, at the same time here, in this session, I'll try to show you that without writing any, without using any third-party libraries, how we can just, I'm acting as a C programmer. Okay, I'm just try to show you the simple peripheral, like how we can start start to implement a small C programming for writing, for enabling that for or toggling the GPIO, or like you just making interface that you want, or making interface that your EEPROM, or making interface that ADC. Sorry, ADC. And they're here ultimately for IoT product development. So I mean to say, not learning that writing GPIO programming, and not writing about that communication programming and all, but the agenda what you must get from this, any kind of open source hardware, how we can just try to work, how we'll straight away we unpack it, and how we just make interface the peripherals. Of course, peripherals is very much playing the important role in making that any kind of product, as I know. Yes, accepted, right? So here, even if you just take it up, this embedded Linux PC, it will act as a gateway in a IoT model applications. Yes. So when we are talking about that IoT, this product development, this open source hardware, we are configuring such a way that the role of this open source hardware will become a gateway, right? So the earlier series already have seen that IoT some IoT introductions and all. There we have seen that there is a building blocks for IoT product development. In this IoT product development building blocks, if you see that basically the major role it plays, that the data points and gateway and cloud. So these are the three components, or three building blocks which is are playing major role in our IoT product development, as you know that. So get data point meaning here maybe sensors, or maybe actuator, or maybe some other like kind of any device data, the data which is we are going to collect. How we're going to
Gopal sir, your voice is not there. Hello, Gopal sir. There is no voice.
hello, hello, hello.
Yeah, now we can hear you. Yeah,
Yeah,
we
yeah,
can
yeah.
hear you now.
Oh, great, great. Thank
Okay.
you. So his was muted, so pressed, I think so. I'm sorry. I'm keep on talking.
Okay.
Yeah.
Yeah.
So yeah. Okay. Basically here, And the basis of IoT product development. Now we just configure this open source hardware. Like so, whatever we are talking about open source hardware, we are just configuring that as a gateway, right? So in IoT product development, there we are having that multiple building blocks. Like we can see that data point and a gateway and a cloud. This is the three components or three variants which we are using for product making. Yes. Obviously it's correct. Now this is here data point, meaning that what, how we get the collect the data. So might be the data point from sensor, through sensor or through actuators or through some kind of other devices or through like any model we going to get the data, right? So the data here we have the data which we are collecting from some which we have connecting to the one of the digital pin. Might be the digital pin is act as an input device, or might be the digital pin act as a output pin. Okay, so from like this, so these peripherals are playing that major role to design or make any kind of product, electronic product. Okay, now in this here the basic thing what I just want to show you today, just that unpack that any kind of open source hardware and how we are going to see that, how we are going to easily work with or interface or collect, how easily we can able to get into the board, how we can easily get a little bit hands-on without writing any application program. Okay, so how we are writing the how we are accessing the peripherals. Very first key point, we please understand, very frankly speaking, this session is very much helpful to that those who are migrating from microcontroller to embedded Linux startups. Okay, so here already I was discussed few minutes back the Linux and embedded Linux variant differences. Okay, so whenever you configure that any PC or open source hardware with embedded Linux, okay, you're configured that with embedded Linux, the open source hardware with embedded Linux, how we can try to interface those onboard peripherals. Apart from that onboard peripherals, like how we have the expansions, how we have to create a data point on this particular hardware. Okay, so how it is can be accessible or usable. I'm just telling that irrespective of, I mean, there we have a multiple open source hardware we have in market, like Raspberry Pi, BeagleBone, Panda board, BeagleBone, like open friendly 5-board Vega, 5-board Riga, 5-board, like we have a multiple source of open source hardware which is present in market. So now, as a fresh engineer, how we can able to get into that board, how we just easily access those peripherals. That is what our motive objective of today's session. Please, I hope I've created the expectation of yours. Okay, now slowly we'll get to enter into that the terminal, and I'll just show you the how the board can be bring up. Okay, so once the board get boot up, so we'll try to see that how we can write a small basic hello world program, and how this hello world program can be execute or work. Assume that this is application program, like somehow fit your like your GPIO or some other. Okay, this hello world program, how we are just testing into that your hardware. Okay, now very simple key points here. Just have a patience. I'll try to show you the terminal. Now here the board is booting, and this embedded Linux, as in our previous sessions already Vasu sir was discussed about that all these components which are enabled of this footprint, like this embedded Linux, what exactly is configured and booted with the how many limited number of services. Okay, so exactly I can say you one thing. I can say you one thing here. This limited footprint is ultimately very less than 5 MB. The kernel source it is. Okay, so now by using this hardware, like here root at rugged board -A5 GTX, as you know, the previous those who are attended the previous sessions already, they know about the configurations and specifications of this hardware. I don't want to waste your time, and straight away we'll just get into the board usage. And now here very simple. Now I just want to execute a small hello world program. What I have to do then for to execute a small application program? So what I have to do that? So I just want to again have to interact with the Linux PC. Yes, obviously. And there I have to write the small program. Yes, I have. Now I'm just opening that another terminal here. In this terminal, so this is my PC. As you know, this is my PC here, and the other terminal which I am using, that board terminal. Now I told you that very clearly that now we are working with the two PCs. One is the Linux, and another one is embedded Linux. Okay, if you want to do execute any application program in embedded Linux, straight away can I able to do that in embedded Linux board? By sometime it's possible, but sometime it may not be possible due to the limitation of this memory usage. And there is a some of see, if you ask me write in a Python programming and straight away in a board, I'm just okay. Like, but the thing is that the if you ask me to write in a C programming, but there is we don't have any cross compiler over there in my embedded Linux board, so that I'm hands up in this. Okay, so now what exactly what we have to do? So here we have to come to that your PC terminal, and just straight away I'll write a small here cd now cd here int10, and here I'm just writing a small demo program here. Now hello world program, as you know that. Okay, now see here. Guys, please don't feel bored. Those who already know about this, but this technical session is only for those who are new to Linux. It's very much benefitable and helpful to them. Okay, so now here I'm just compiling this demo.c -o demo here. All right, so I'm just creating that one of the executable for that. So can you guess it? What is the file format of this file? What is the file format of this file? Yeah, here I just I can show you here. There is a list of files here, and there is a demo which is visible here. I'm just executing now. See now, hello world will be displayed, correct? So if I just copy this binary straight away into that into my embedded Linux hardware. Okay, so in my embedded Linux hardware, if I just copy that, it definitely it will scold you that. How? Why? I'll show you the reason here. Now if I just ask you to boss, on what architecture this binary was created, you ask me now, it will show you that. Boss, I am just created this. This is for LSB executable 64 LSB executable for x86 64-bit version it is. So now you are not able to run this binary into your board itself. Okay, so for that what I have to do that? Now I just want to run this demo program into my embedded Linux PC or embedded Linux board. Okay, for that very simple, so please try to understand here. So here I just want to take that one of the cross tool chain here, GCC whatever I'm using now. GCC, whatever I'm using now, this is purely for x86. This guy will not be able to provide the binary for my embedded board. This GCC is a native compiler. So the native compilation part will not be applicable into that my embedded board. Okay, so for that, what I have to do, I just go to the cross compiler. Cross compiler, what it do? So there is a ARM cross compiler we have. So here this cross compiler, here we have, I have a compiler source here and now. So just a minute. I hope it is visible. Yeah. I'm just making change the environment for this compilation toolchain. Okay, now so here we have a board specific compiler toolchain SDK we have. So we just try it away. Those who are like having the board, might be they will get it, that is this SDK. Even we have a other even our regular board community, you can straight away download this toolchain. And so here making the change the environment from the native to cross. Okay, now I straight away execute that script and running that environment of the ARM GCC toolchain. Now how we can make a cross check that this toolchain got changed or not. ARM hyphen double tap. So now there we can able to see that this is what the list of the GCC tools. GNU committee was provided that there is a C and C++ and Java programming languages. We can straight away compile here and something wrong, and straight away we can compile here. So here we can directly you can use the component the GCC C or C++ or Java tool you can use and to compile your application and generate the binary. Okay, so now I'll try to show you that. So here we have now enabled. Just a minute, I can just show you one example here. Yeah, previously we have intent folder we have, and this intent folder I'm just taking that the demo program here, demo.c. In this demo.c, no rocket science here, simply hello world program. This hello world program, how we can able to just you can able to see here I'm just compiling them by using $GCC, which is already mapped with a macro with a ARM Linux GCC GNU BI, so that we no need to write that complete the tool whatever we have in a the ARM hyphen double tab what I shown you the tool. So we no need to write the complete the line of the GCC. So we make shortcut them $CC here. So demo.c hyphen o demo ARM file. So this is the one binary I'm just creating here. Straight away you can able to see. Yeah,
Gopal sir, sorry to interrupt. Can you please close those pop-ups? It's kind of interruption.
Okay. Just a minute. Yeah, all right. Somebody's talking, right? Srinivas? Somebody, could you please mute them now? Yeah. Yeah, okay. So here we have straight away generate the binary for which is purely specific to that your hardware or open source hardware. So now if you ask me to run this binary, straight away your x86 PC will scold us, like, see now, yeah, array boss, I cannot be executed because the binary file format error. Okay, so my dear engineers, please try to understand, this is a key point to very first you have to understand how the binary which is got generated, the binary which is purely specific for your native or cross compiled. Okay, now see here, the same demo arm I have now file followed by demo arm. See here, yeah, so now here you can see here the demo arm ELF 32-bit LSB executable, it was ARM compatible binary got generated. So this is what the first assignment or first task the engineer who are migrate from microcontroller to microprocessor or open source embedded Linux users or programmers. Okay, so this first activity, once you just understand the key point, the secret of this, the binary file format for native as well as cross or target specific, then you are into cross the 10%. Now out of this 100% of embedded Linux programmer, you are now cross that. I can say you that 10% you are now enabled to you're qualified to use that open source hardware. Okay, yeah, come to the point here. Now I'll just switch to that our board. I'll switch to that our board here. Now 1 2 3. Yes, I'm switching to the board here. So here I have, so there is a data folder, as you know the previous sessions demos you have seen that, I think so. Here we have a list of binaries which we already copied. Now you may ask me one point here, sir, how this embedded Linux got booted up. Okay, so now I can say you answer here straight away. This industrial grade hardware or open source hardware, ultimately every open source hardware, there is a few options here. One option is through SD card, we can straight away flash your OS image and you can boot it up. And other way is the NAND, other way is the NOR, other way is that eMMC. These are 4 different ways we can bring up your embedded Linux board. Okay, got my point? Yeah. Now once you start bring up, okay, now you're booted and as like your Linux PC, your embedded Linux board got booted and it was provided the terminal and console we got, and in this console how we just straight away we'll just execute our the application programming, our eLinux application programming. Today's topic, based on that, I'll try to show you a small some demo program to that user onboard peripherals. I'll try to make you understand. Okay, so you can please see that I'll start execute dot backslash demo 1 or demo already demo is also be there. Yeah. I was copied earlier, but yes,
Gopal
yes.
sir, can you hear me?
Yeah.
Gopal sir, can you hear me?
Yes,
sir,
yes,
you are
Srinivas.
sharing your screen or chatting?
I am screening my
Okay,
screen,
okay,
right?
right.
Yeah.
Now only I'm able to see basically. Okay.
No, it was earlier. It is yeah. No, right. So here, I just missed my sequence here. See now. Okay, let see this. So once you execute the application program dot backslash demo, it will straight away execute and display the result. Okay. Now in this, you ask me one more question here, sir, how you copied this binaries or application binaries into the embedded board. Okay, my dear guys, I can show you, I can tell you three options here. Through SD card, we can direct straight away. It's a basic level. Just copy your binary from your host through SD card, and straight away you plug into that your board and you can access. Okay, and other one is that if you it's of course straight away more times if you are just keep repeat. Usually it's a burden to that keep plugging the SD card and plug out the SD card. It's a kind of burden program. So for that, to overcome that, we have a TFTP. So through TFTP also we can able to transfer the file from the host to target. Okay, host to target. And the other way here we have transfer the file through minicom or through USB serial also we have, but ultimately here you can copy the data from a host to your target. These two are the best options. Okay, basic level you can use SD card, and the advanced level, if you are very much get hands on through that, you are just configure that your Ethernet or a TFTP to your embedded board and your host PC is how fastly you can transfer the file without any kind of disturbances. Okay, that's one point to note it here. Now, well, straight away we'll go to that peripherals. On board we have a peripherals. Onboard peripherals we have, of course, even though we have a onboard multiple open source hardware today, you can find that LEDs and buttons and expansion slot to user friendly or directly end user easy usage part. Nowadays open source hardware come up with a open GPIO, open hardware accessibility. Okay, so now for that, I'll tell you one point. So you want me to write application program now? Okay, so I'll write it. But before that, Are boss, I'm very much no. I have a only basic knowledge of C program. How can I write a C programming? Okay, you are open that your hardware, and I just want to try to try to just interface that, or try to just test that peripherals, how it is possible. There is a chance here. There is a one of the virtual file system called Session-6, through which the Linux kernel will straight away access your low level hardware. Okay, so now I'll try to show you one example here. One onboard peripheral, how to access through Session-6 here by using echo command here. So now one more thing here. Here we have to write a GPIO number. Here we have to write a GPIO number. How we can write a GPIO number? So but again we have a calculations, but the vendor will support you that. So the manuals, hardware manual which is available with you, right? So you straight away calculate the GPIO number. Okay, here I'm just trying to show you the example here with PC13 is onboard LEDs available. As you know, previous sessions we have seen that, but straight away I'm just going with the same here. Now PC13. So here I'm just writing that PC13. No, it won't accept. It will ask you that, boss, I need the word one numeric number, I don't want to take it up. So here we have a ARM controller, we have a multiple parallel ports, GPIO parallel ports here. The parallel ports, it starts from PA, PB, PC, PD like this. Okay, PA it starts from 0 to 31, and PB it starts from 33 to so on. And each parallel port it occupies, or the register which is a 32-bit more 32-bit registers we have. So like it is it starts from PA0. So PC it is a PA0, PB1, PC2. Now 2 into 32 plus 13. 2 into 32 plus 13. Yeah, please, could you please tell me anybody what is the value here I can write? So okay, I'll write it here, 77 here. Now I just I'm using that sys class GPIO. Okay, I'm just making enable that the GPIO. So we are making enable that GPIO, and straight away this port get created and exported to the user interface, user space. Now your echo. And you ask me one more thing here, sir, you are just making use of that one digital pin. That digital pin we are configured with what? Either we can configure with input direction or output direction. But here that 77 which is enabled, or 77 which is registered with a LED. So that what exactly the direction I should make it here? Output direction. So now here greater than symbol says class GPIO, and you now it is what exported to that user space PC13 here. PC13 here, followed by what I can give it direction. I just make it up. Direction I was made it up. Now what exactly we are doing now? We are just making that we are taking the GPIO, the user space, and we are configuring that the GPIO to the output direction. Now it's straight away. Now you can use either high state or low state or glow. How would you want just to do that? So now here to see here echo 1, and or straight away I just make it up 0 and sys class GPIO and PC13 here and value. So straight away I can able to show you once I just make it on my video here. You can able to see that. So here the green color LED. Guys, please don't feel bad or don't feel bored, which is already run over the previous sessions, but it's a new who are like the new participants to easily you can understand. But since I'm just moving very fast, but you please bear me. This is the session which is recorded, and you can you can easily repeat again back. Okay, so now so here this is the first level of testing your peripheral, how easy unpack the board, how easy we can just touch into the LED and touch the LED or Genie GPIO button or anything. Okay, straight away we can able to work it out. Now I just want to become a programmer. I just want to make this use of this. How many of you are C programmer? I don't know here. By using these 4 steps of this lines or 4 steps of this commands, by using these 4 steps of commands, we just build that simple program, and we can ask them to toggle that. The 77 whatever we have. So okay, we have a limited time, so that I'll show you the program. And you just see and enjoy. And those who are programmers are there, you can straight away see and understand how we are just framing this. Very simple here. I just use that one files concept here, and we just try to open that this macro with each command. I was registered with one label. Okay, no need of talk, and I'll straight away project the program here. Yeah, okay, now see here. Now hope you are looking this. Yeah. So here very simple. I'm just taking that some of the headers which is purely recommended, string.h, stdio.h, lib.h, types.h, function control, unc.h. See now, very simple. You just feel very funny here, and but the thing is that how smart way we can able to program that the commands which are straight away without writing any application program, the commands which is already we are experienced it on the terminal, how we can make them program, make them program with the comments, with those commands here. So here GPIO enable sys class GPIO export. I will just create a labels here, and straight away we are just opening that port here, opening that label here, open GPIO enable with a write and read mode only. Straight away we are just asking that exceptions here if that open. Now once here we are very much of course programmer, you can understand. Once open call is successful, what it returns? It returns that one integer number, correct? So now this fd, as and when is greater than 0, the next statement will be going to be executed here. So now I'll just make it up straight away up. So here whenever it is open is not success, okay, what it is returns that it's 0, okay, or -1 on success of this API, open API. So of course if you want me ask you that what is the syntax for open call, if you have any freshers are there, I can just man page straight away, you just use that man space to space open, you will get the signature of open call. All right, so on success of open call, it returns that some integer number, that integer here we are evaluating that with that. So if it is good, like integer number, non-zero value it was generated. Now this non-zero number, we are just we are taking that GPIO number 77, which is already I've seen that in a command prompt. Okay, 77 is our GPIO LED, right? Now here this GPIO number I am just taking into that buffer, and this buffer I am straight away writing on the file descriptor. So write API is one of the function API which is available, man space to space write. So there we'll get the signature of write call also. Once it is done, I'm just closing this, and here we have again we'll try to repeat this same procedure for the other two commands also. Okay, again we have opened that GPIO direction, we are asking to set the direction, and after that to configure the direction here, the direction with the 3-letter string which we are writing out direction here. And once it is done, the direction set, what the final thing is there, we are just using that write APIs, we are toggling the toggling the value here, toggling the of course number, right, 1 and 0. Sorry guys, I've just you please it's a one apologize. Actually I just want to show you with some APIs functions, some functions separately, but within a time limitation, I'm just straight away projecting the this application program. Don't feel bad, but here ultimately what you must understand that how we can make program this commands, only the point here to understand. Okay. Right, so now here what exactly we'll try to do that. So similar way I'll try to compile this program. Here, and now where we have so Alt1, here we have so desktop, here, and so tech tool session here, and so here we have $cc followed by GPIO.c -o says GPIO. See this here, and now it was count undeclared. Okay, so I was just make that program GPIO.c here count. Yeah, sorry, it just displayed by mistake. So now here how we just cross check that. Similarly here file followed by sys GPIO. See now it is specific binary which is 32-bit. Okay, Now I'll try to show you the execution part here, where we have our terminal. So here we have, here you can see already I was copied that sys GPIO. So straight away we can just run that sys GPIO. So enabling the GPIO, configure the GPIO direction and all. Now it is blinking. I'm just making on my video here. You can just see this. So the green color LEDs got blinking here. So you can easily find out. So it is straight away a simple program, how we can able to write an application program for GPIO peripherals. The same how we can write a button, we can write without using any third-party libraries, how we can able to write interfacing. Okay. Yeah, sorry. Now the other thing is that next. So this is the one we can try to see this. How the GPIO we can try to interface after unpack your new embedded board or open source hardware. So straight away, especially in our rugged board community, you can able to see that we have in a spoon feeding model. We have just make the all sequence of commands. So straight away you can copy those commands and you can enjoy the board usage. Okay. Now next come to that within the time is rolling. Next I'll show you one more interface. That interface here we are talking about that UART. It's ultimately very important tool or very important peripheral, especially in IoT product development. Okay. So as and when you want the data, you got it. Once the data you got it into inside of that your embedded board, how we just communicating with others, or how we are just establish the communication between that your gateway to the cloud. So one way we are just using that the Ethernet communication, or one way you can use that Wi-Fi communication. And the one way we can use that in the in-house, say for example, here we have Bluetooth, or say we have. So here one of the important peripheral we are just going to discuss about the serial communication, UART. Okay. And my dear guys, within a time period, I'll just close it this how easily we can write a small open the port and write something on the port, and how to read the port. Okay. So basically, as and when I just switch on or get my board control, how do I get the board control to my Linux PC? Did anyone observe? I'm just using that Minicom tool. Okay, so the Minicom is also one of the communication tool in Linux operating system. It's a serial communication tool. Now if you ask me, I can just reboot this. I'll just come out from this this terminal. Yeah, so now see here, sudo minicom-s. What exactly S refers that? I'm just asking you that how we can configure the port. How we can configure the port. So the port which is needed, there is some few parameters we have to initialize them. So those parameters, see, by practically if you see that these parameters, serial port setup is there. These are the list of parameters it is asking you to before establish the communication. Just make sure that your socket get ready with some information, some information it is, whatever. So here the port which is the device which is recognized /dev/TTY USB 0. See now, those who are new to this Linux part, so as and when you plug in that in your USB to serial converter, or directly you can use that your USB terminal, USB socket, RS-232 port, or DB9 connector. So once you connect the DB9 connector, the very first what exactly you have to try to understand, there we can use the command called dmesg, DMESG. DMESG. I'm just once again come out from this. Okay. So here I'm just connecting to that. I'm like here DMESG. So here this will ask you that. All right. So here we can find out we can find out TTY USB 0. Yes, TTY USB 0 got connected here. FTDY USB serial device got connected here and disconnected, and again we are attached that USB device like this. Okay. Once this is, make sure that your port is enabled, then you can ask that boss cd minicom-s. Okay, so now it is asking you that you just please configure the port, the serial port. So here I'm just configure the serial port with the serial devices this, and here we have the bits per second, the 115200. Here we have hardware flow control no, software flow control no. Why I'm just discussing these things, please understand this same whatever the minicom tool will try to develop same minicom terminal to access our UART devices without using any ready-made tool. How we can able to design that our own minicom tool? So if you want to design your minicom tool, you must know that how we just what are the basic parameters which is needed to configure the port. So make your port get ready. Okay, so how it is possible? What are the basic parameters are behind to make initialize to get ready that your port? So all this is very important to know, right? Once it is done, now we are just making it as a default, then come back to that your exit, so your terminal get ready. So means my board is I'm just getting that control of, means the console of my embedded board into my PC. Please try to understand. So how it is possible? Through serial. Here we have a FTDI chip, there we have a USB serial converter is there, and straight away I'm just connecting that my USB through USB serial converter. I'm enabling that just get the board control to my PC itself through serial. Got my point? So now in this aspect, like how we can access the serial peripheral or UART peripheral. So as you know, on board we have a two UARTs are there, TTY S1 and TTY S4. LS, okay, ls/dev/TTY star. So here we have S0, S1, S2, S3, S4. Okay, so here you can see that. So you can straight away either you can use that S1 or S4. Okay. There is one more tool called microcom, and by using this microcom we can straight away test this how this port is got activated, how this port loop back, how we can test it up. Of course TX-RX, once we just make short it up, whatever we are just giving that data, it will be get reflected back to the user space. Okay, user space. Through that loop back we can easily test your UART without touch or without write any application programming part. Of course, that is also we'll try to show you. And now come to the programming part. So if you see that program, very simple. We are making open the port with /dev/TTY S1. Okay, just let me give you give me one half a minute. I'll try to show you the program how it is and before that, my dear friends, see if you want to write any UART serial program part, you very first you have to get into the more information into there is a structure called TermiOS. Man space. Oh, sorry. 1 minute. In this not available here. Man space TermiOS. So here you will get a lot of information about that your serial communication, how we can write, how we can interface that your UART peripheral by using this man page. Total man page will give you that to understand the complete hands-on on the how serial port can be configured such a way that in a fully configured, with a how the data flow, what time it is the data can be buffered, what time the data can be released. So ultimately you just love it, this man page, and the data which is available here. Once you see that my program, you will understand the ultimately this man page, the complete man page is nothing but your program. Okay, so I'll show you. Just see now. This is the one structure, TermiOS. This TermiOS structure will provide you some basic input flags, output flag parameters, structure members like input flag and output flags, and modes and control modes, local modes and special characters. All this information which is available in this. This is a beautiful man page for those who are wants to work programming or interfacing to the UART. It's an ultimate man page. Okay. So because of time rolling, so I can't make you explain all these options and all, but when time permits, and still again one more session will make it separate session for this, especially serial programming. It's awesome, like you can enjoy the session only with this the interfacing with any Zigbee, or interfacing with any RFID, or interfacing with Bluetooth, any UART compatible device. If you just take it up, how we can write us interfacing application part for that by using this man page, you will enjoy this. Okay. Now, so here the other thing is that the application here you can able to see that UART. So here I'm just showing you one of the transmit program and one of the here. Yes. So these are all the options are not recommended, but if you want to fully configure that your serial port with all particular here, I just used it that all options to make you understand, but right now I can't explain that all the options right away. Directly I'll come to the point here. There is a structure called TermiOS. We just created that object for that, and here we just straight away open the port. What I shown you that ls/dev/tty s star. I'm just using this /dev/tty s1. Once port is opened successfully, the port which is configured with all these options, and straight away we are setting that attribute instantly TCSA now. The first argument of TCS get attribute is what? FD, that is return value of open call, and second argument TCSA now, meaning that reflected immediately whatever the initialized options it is on this structure member, and we are passing the address of here passing the address of the structure, and get attribute here. Straight away we are writing the data on the buffer itself. Okay, as simple. This is one terminal, and the beauty of thing is that two terminals we can open at one terminal. We can straight away run this transmit part. Another terminal we can straight away run the receiver part. Okay, so there is a APIs called read and write and send and receive. Okay. So straight away we can use read and write APIs. Even those read and write APIs are very much you can get the information about with the man page. Okay, with man page. See, Linux is a contributed kernel source, so that it's an open source. Everything is available. Man pages, ultimately all APIs are man pages are available. Only the thing is that as your programmer, just have a patience and just have a spend the time on it. You will become a good programmer in special instances. But especially what the difference here is, here we are using the GCC compiler. The Turbo C compiler already earlier the engineers used, right? So there we are using that IDs also. But this GCC compiler will provide you that more number of keywords. Okay, so the more number of, ultimately it is provided that 60 to 70 keywords it was provided. Okay, so you can enjoy a lot with this open source, this GCC community. The other program here, now I can show you one more here. Yeah, receiver here, one recv.c program here. You can observe straight away here. I didn't use that all options here to port configure. I didn't use that all the options here. I just make that only software flow control and the parity enable, and here we have the baud rates, then the number of character which is used to the waiting time to get the characters, all like we just configured in such a how much it is sufficient. Okay, so I was straight away come to this. Here we are just reading the data here. There is a small demonstration. Mr. Arvind will show you this UART, how the data transmit receive. Okay, and one more I have because of it is 118. The last interface I'll try to show you, and finally just bear that next 10 minutes will complete the demos of UART and I2C and GPIO also. GPIO I was covered, but the UART and EEPROM, he will try to show you the demos with a board, with a image full clarity picture. Now here, see now. So here, this is a receiver part. Due to this time limitation, I am unable to present you in detailed all those things. And now here we have one more interface, last and least. Here we can just see that EEPROM. Here while putting that board, if you see that, Alt1, I'm just rebooting the board here. Here we have internal memory. Sorry. Here you can see there is one EEPROM Atmel 256 byte 24C02 EEPROM, which is inbuilt available. Already I have written that 8 bytes on this, so we can test it with that also. So the memory chip which is having that internally 24C02 EEPROM, and I'll try to just show you that it is with I2C interface, I2C bus interface, which I'm just using now. Even you can try. There is a I2C detect command which is available here, and 0. Here we have. There is a, here we have on 52. 52, there is a one EEPROM got detected. These are the devices which are registered here. The bus which is registered, 0 bus, which is registered with some number of I2C devices which is registered here. And now I can show you here cat followed by sys class I2C. This is the one easy way we can able to test it. I2C adapter, I2C 0 bus. Under 0 bus, here we have this EEPROM. See now, which already there is some data which is written here, memory 24C04, which is copied. But I didn't write. Right now already, which is what exactly the memory content I'm showing now. So if you want ask me to write and show you one thing here. See now, just echo. I'll write hello world. Hello world followed by sys class I2C adapter and I2C 0 and 000 -0050 EEPROM. Okay, now I'll just use the cat command here, and you can able to see that. Yeah, I hope you can see that it is overwritten on that the previous part. Okay, so hello world, the program it is displayed. Now last and least, I'll just explain you that EEPROM program, how easily without using any third-party libraries, how easily we can write by using this command itself. Only just using this command, how we can able to write a simple C program. Okay, nothing, no rocket science here. Instead of writing on a command prompt, how we can able to write a simple generic program to make use this command and write and read the data from this peripheral. Okay, yeah, I'll just show you. Please have patience. Please try to see here. Nothing. There is very simple to understand. Very simple here. Now, I'm just taking this this complete command into one of the array here, and now here we have better. I try to show you in a gedit. It's gedit. Sorry. Yeah, so here you can able to see the complete application. I'm just taking this command into the array. We'll come back to the main program. We'll come from the main itself. Here I'm just taking that one of the structure objects to objects here, and keyboard and EEPROM here. We just try to access the structure members like module ID, serial number. At command line, we used to pass the data as well as serial number, the model number of the memory device. At the same time, I'm just taking that the complete the data from the structure. We are writing on write board EEPROM. That write board EEPROM which is defined here. Right, board EEPROM is defined here, and we are just taking that the written yeah, we are just opening that command with read write only, the same as previously GPIO example model we did, and here the written value ft, and we are passing the address of the structure, and we are writing. That's it. And still we are even same model, we are reading the data here, and here I'm asking to read the structure data here. For that, there is a read definition which is available here. We have tried again open the file here command, and we have tried to read the data. See, write and read APIs which is straight away available with the man page. The syntaxes easily you can get it from the terminal itself. Okay, that's it. So. I'm really sorry the time rollout. So to enough explanation on this, I'm unable to do that. But still there is another open session. We'll try to do that, especially for each session for one peripheral. We'll try to do that. Okay, please bear me. And now I'll just hand over to the Arvind to show you this UART and I2C demos along with the GPIO if possible. Okay. Arvind, are you there? Hello.
Yes, sir.
Yes, sir. Yeah, could you please share your screen? I'm just stopping my screen, and please next 10 minutes, please you make it. Yeah, this is GPIO. As earlier, what we have seen that Blinky GPIO, the GPIO. That's right away by using these three commands, we make that C program, and we'll try to toggle them. That's it. No rocket science in this. So easily you can find the demo here. Okay. Next, Arvind. Next, go to the UART. So in this, we are trying to show you writing and writing the messages here. As and when you just make short the data which is written on the port, it will start read it. Okay, so it's a very superb application. You can enjoy a lot once you start two terminals even there is a one straight away demo we have on board. We have a two terminals. One is that UART S1 and UART S4. So if possible, you can just in real time how we can make it up. One we can connect to the GSM, one we can connect to the GPS. Okay, so from GPS we just receive the data through GSM. We'll just push out the data to the mobile or any end device. Okay, so on board is an advantage to that. These two peripherals two UARTs straight away one shot we can able to use that. Okay, one you can connect to the GSM, one you can connect to the GPS. Okay, or Zigbee or whatever we if you want to send this data to the local, straight away we can use the Zigbee or Bluetooth. From GPS we'll get the latitude, longitude, and we straight away push to the local server itself. Okay, that's one of the beautiful application we can able to do that by using this UART peripheral. Okay, next I2C. So there is a I2C bus inbuilt EEPROM which is available. Already I have shown that in a board bring up by the time board boot up. So here straight away we can with the program you can how we can able to test it. Okay, you can able to see that. So there we have a module ID and members. Of course, these are wrong information. Of course, we can just straight away you can how we are placing the data inside. Arvind, you can just show with echo command. Echo, sorry, cat. Yeah. Welcome members. Yeah. Okay. So straight away it is just overwriting on the particular address memory on a particular address memory, and it will just we can read the data. Okay. So now it's at 1:30. I'm very sorry. Additionally, I just took that 30 minutes more. Now it's done from my side. If you have any questions, please you can ask me now. So let we have question answers part. Yeah, Srinivas, I'm just done from my side, and you could take the question and answers, or else we'll just yeah.
Thank you, Gopal. Yeah, so it was a lengthy session, but it will be very useful for the participants. Yeah, so we will go ahead and take some time for questions now. Just a reminder, please be sure to type questions in your chat box in your control panel. Okay, so you can ask your questions. And one more reminder, if you, in case if you want to give any feedback, you can find a feedback form in the chat bar. You can give your comments there. Yeah, so it looks like we have few questions. Give me a second.
Yeah, I will just take the some questionnaires here. There's somebody, Kiran, could you please publish this sample code on Git? Yes, already it was there in a community, just developer.ruggedboard.com. You can see that. Gopal sir, could you recommend a book for mapping the topics and learn about these libraries used? Definitely, sir. So straight away here we will get a lot of data in our rugged board community for especially for to usage of the open source hardware. And apart from that, there is a embedded Linux books are there. You just Google it. There is a, of course, even we'll try to give you an offline. There is some more if we have. Okay. Your feedback will okay. When is the next session and on the what topic? There is Ankit Prajapati. He's asking that next Saturday again we are planning to conduct on a particular one peripheral, especially for a unique topic for to get a more information, dive into that the particular peripheral. Please, I mean, let you know. I'll just on schedule itself. You'll come to know how where you are transferring binaries from your PC to rugged board. I told you that I answered this question in a session itself. There are two options here we have. One is SD card, one is the 2FTP. TFTP we can. TFTP also possible. Yes. Due to this, my Ethernet card, once I connect to the Ethernet, this Wi-Fi will come out. I mean, will lost that Wi-Fi. So that's why I'm unable to show you the TFTP transfer the file. So offline, or you can try. We'll try to help you at any cost. FreeRTOS supported on this board. Yes, exactly. FreeRTOS is ultimately supported. 100%. Yeah.
Yeah, actually, one more question is there from Saravanan. He's asking, cannot we do the code compile and running inside the rugged board directly? How do you move? How do you moving the binary code into the board directories?
Here we have see now if we are working with the Python code straight away we can write it onto the board, but when you work with the C programming, C applications, there is no possible, because due to the limitation of the memory and all, that cross tool we can't able to enable into inside the board, so that we have to make cross compile at a host side, and we just transfer the binary to the board itself. Hope you understand. What is the difference between GNUB and MUSL GNUB toolchain files in the toolchain directory? Here we are using that two variants, and Poki and Linaro toolchain. That on that variant it was showing that MUSL and the Linaro. Only the flavor changes. That's it. But here we are using that Yacto toolchain. That's what it is showing, that MUSL GNUB. Could you please close this to close those YouTube pop-up and okay. Yeah, I did that.
Yeah, Gopal sir, few more questions from our YouTube channel. So yeah, there also like a good amount of responses were there. So there like the students, I think, which bootloader it uses in our rugged board?
Basically here we are using U-boot. It's a generic bootloader I am using now in the rugged board, so straight away we can use it up. Even we have other bootloaders also compatible, like Bearbox and all. We have other flavors of rugged boards, IMX6UL, and especially in this I'm using that U-boot.
Okay.
He's asking initiation for FreeRTOS with rugged board. FreeRTOS will propose. Will come to know in future sessions. I'll try to get it up. Will come to know FreeRTOS part. In the C API, same respective of a hardware platform. That is, can I run the same code on a rugged board? The question is, Kiran, rugged board and BeagleBone without without any modifications. Hardware, can I run the same code on? Of course, here yes, but the tool chain we just have to take it. Of course, here we are using GCC Linaro tool chain. There we are using that the other tool chain must be. But only the difference here, hardware can be anything. Might be AM335. Your BeagleBone, you are using that AM335. Hardware architecture could be respective. So respect to that, you can use with respect to the tool chain. We can straight away run that binaries. C API same irrespective. Yeah, C APIs it's the same. Write and read all APIs. It's compatible. It's compatible any board.
Okay.
Any more?
Yeah. Gopal sir, yeah, one more question from Aditya Bohra from YouTube. He's asking regarding the bootloader only. Can this testing be done at the bootloader prompt, And one more question, can this testing be done at, yeah, bootloader Pro is asking about the, can this be possible on bootloader Pro?
Testing what actually? What exactly you want to test it? So the question once you just what exactly you want to test it, either like a peripheral testing or like what exactly the testing here. So that it's a very I mean we just ask him.
Sure, sir. Yeah.
Yeah.
One more question from Retinam. Subhaya, how to configure Ethernet to program the target from host PC?
Yeah, there is a socket programming, especially in future classes. I can show you. There is a socket APIs we can use, and we'll straight away we can interface socket with a basic configuration, and like a PC and your board. Your PC act as a server, and your board act as a client. Such a vice versa, you can able to work on it. And there is a one, yeah, there is a one question. UART demo that you showed is for loopback mode. Actually, I have seen that short between TX and RX pin. Yes. So here we have that multiple options. One, we are just showing that loopback. Okay, read and write. But it is just two terminals. I can try. I was try to show you that, but due to time rollout, I am unable to. But whatever he shown that it is a loopback program.
Yeah. One more question from Manikanta Kumar from YouTube. How kernel is participated when GPIO and I2C run the command?
Here, so now kernel now when we are using sysfs. Okay, this sysfs is a virtual pseudo file system which is straight away through kernel. It will directly call to the low level hardware itself. Okay, so Linux kernel is taking the role to access the provide you that your sysfs. So through sysfs we can access the hardware. Yeah, that's what the answer for that. How can we debug our code in target machine, meaning in out our board? Debug here application level or system level. So I can say application level through debugging techniques like GDB and all we can able to debug. Mr.
No, but
Ankit.
GDB based like we have to run the GDB in the board, right? So how can we run the GDB in the board from our host machine?
There we have to add packages, and we can try. We can. So far I didn't try, but there is an option to do that.
Okay. So do we have any session or something for this? Because that is
for
important.
Debugging, especially only for debugging, no. But apart from that, like this peripheral part, we'll try to work on it.
Okay. Fine.
Yeah. Thank you. Yes. Any more, Srinivas?
Is it supporting any JTAG? JTAG or J-Link?
No.
And what is the debugging interface provided on the rugged board?
Still here we are hardware debugging. We didn't do so that, but only the software debugging part we can. That I can just work with our system engineer. I'll try to get back to you.
Oh, sure.
Yeah. Srinivas, any more questions?
Yeah. So the question from Aditya Vora. So he's asking for the like a GPIO and I2C memory modification can be done at bootloader prompt. He's asking like.
Srinivas, his voice is breaking. Could you please repeat now?
Yeah, sorry. Yeah, can we debug the code application? Yeah. So one more question. Sorry. Yeah, from Manikanta. Can we debug the code application using GDB and KGDB? Which one is the best result?
KDB is not like a GDB is the one application debugger. Straight away we can use it to debug your whatever applications part.
So Mr. Vohra is asking whether GPIO on the I2C memory modification can be done at the bootloader prompt?
GPIO and I2C.
Yeah.
Bootloader, at bootloader we have options. There is we have the commands. We have a commands to variance the memory optimizations. Through the commands, it's possible in a bootloader. Yeah.
Hello.
Yeah.
Hello.
So one more question.
Rugged board is developed by Phytech. Yes. Ankit Prajapati. Yeah, Rugged board is one Phytech India product.
Okay.
Yeah.
Yeah, I think we can wait for a couple of more minutes. In case if someone want to ask, they can ask their queries.
Yes, Srinivas, we can collect. We can answer offline later.
Yeah. Okay. Yeah.
Yeah.
Okay.
So now it's a 42. We'll wind up here.
Yeah. I hope. Yeah, we can wind up. Yeah, I think it looks like we have covered all the questions.
Yes.
Yeah. Okay. So great. Great, everyone. Thank you, everyone. We
Yeah,
appreciate
thank you
you
very
are being
much once
here.
again, everyone.
So, yeah, our next session, it will be a next week Saturday. Okay, either on Sunday.
With
So
a new topic, I'll come back once again. Definitely will. I'll just fulfill that your expectations on individual peripherals. So we'll have a good technology sharing. We'll try to share the more technical information on, especially with the multiple open source boards. Okay. So thank you very much for your participation, guys. Once again, thanks a lot. See you.
yeah, thank you again for everyone joining us today, and we will see you next time. Okay, bye, everyone.